Okay. So, just to recap, because I just started videotaping, similarity means same shape, right? Difference between similarity and congruence is congruence means same size and shape. Very good. Same size and shape. Very nice. We went over ratios again. We understood what that is. We figured out that the ratio is like the multiplying factor, something like that, right? Similar polygons, the corresponding angles are what? Congruent. And the ratios between corresponding sides are same, equal, right? So if this triangle is 5, 3, and 6, if this side is 12, what we're aiming for now is solving for this side, or solving for x. We say this side is x plus 4, okay? But what do I know this side is equal to? 10. So if this side is equal to 10, then I can write a little equal sign there and say equals 10, right? Yeah. And so I have my equation x plus 4 equals 10. Subtract 4, and I get x equals 7. 6. Calm down, I'm a math teacher. It's alright. I can only do it if I count from 1. Okay? Give me a break. Okay, so x equals 6. Very good, class. Now what about if this was y squared minus 3? Okay, I say this side is equal to y squared minus 3. But this side is 3, right? And the multiplying factor, the ratio is what? 2 to 1. So if this is 3, this is twice as big. This triangle is twice as big as this one. Then if this is 3, this side is 6. So I can make a little equal sign there and say 6, right? And then I have y squared minus 3 equals 6. And what do I do? Add 3. Y squared equals 9. What do I do now? Square root of both sides. Now, and then I write y equals 3, right?
No, you don't. Sorry.
Yeah, negative,
You
negative,
don't.
but negative.
You just,
No, I know who's right, sorry.
I know, me too, I don't know.
So apparently if I just stare at you without saying yes, you guys get really
Positive,
uncomfortable.
negative.
Yeah, I think I'm wrong.
Positive, negative 3.
What was that?
Positive, negative 3.
Plus or minus.
Wow.
Anytime I take the square root, right? Because what's negative 3 squared?
It's
9.
Oh, no.
9.
If y squared is equal to 9, then I could say negative 3 squared is equal to 9. So y is equal to plus or minus 3. Okay? Good. So you'd have to write that. If I asked you what y is equal to, you have to say it's equal to plus or minus 3, Mr. Manir. Thank you very much for trying to trick me, but I won't fall for this trap. Not this time, at least. All right? Okay, so is that, you could. Is that, do we understand this? We did algebra, good job. I mean, it is a good job. You guys are great. It is really good, though. And you guys understand this, right? The concept. What's the major geometric concept?
Algebra. Similar polygons.
Similar polygons.
Formulas.
What corresponding angles are?
Congruent.
Corresponding sides, the ratios between them are
Congruent.
equal. They're the same.
thing.
Right? That's it. Done. Done. Okay? Now, from there we can go in a million different directions if we really want to. And you'll have homework, which is due Monday. It's not that long. It's a significant amount of homework. But it's only because I know that you guys know this concept pretty well. All right? So for those of you out in cyberspace, do your homework. So now, I mean, I could give you something else, right? Let's say I draw 2 new triangles entirely.
Ow.
Right?
And I could stick on around that.
I didn't even notice that.
I used to be
No, no throwing paper in class.
And I say, I have these two triangles, clearly not drawn to scale, but they are triangles. And I ask you, are these triangles similar? Are they similar?
Yes.
You say yes. How do you know?
Number 4. Ratios.
Same
Ratios.
shape.
Ratios 4. Whatever it is.
Can you give it to me in a way that kind of uses that?
4 to 1.
The ratios between corresponding sides are equal. Good. What's the multiplying factor here?
4.
Times 4, right? 5 times 4 is? 2 times 4 is? 4 times 4 is? Buenísimo. All right.
Like that Spanish. What's that?
Oh, right.
Are these two polygons similar?
No.
Hmm?
No, because of 5 and 9.
Nah.
Why not?
One.
5 and 9.
Ratios.
5 and 9. But wait, look, the ratio multiplying factor is 2, right? 2 times 2 is 4, 4 times 2 is 8, 1 times 2 is 2, 3 times 2 is 6, right?
5 times 2 is 10.
Wow.
Yeah.
Oh, so what you're telling me is that I can't just have one. What about just one? I can have one side that's
No.
Maybe.
Can't
We might make it slide.
I?
Nah.
You're using subtraction.
No? I can't have one side that's not. And they all. Okay. Ah. So I should make this. I should change this, right? All. And all. You're right.
Right.
You're right. It can't just be 1 or 2 or 3 or 4 or 5. It has to be all. All the sides all the corresponding sides have to have the same ratio between them. Okay? Fairly straightforward. Now, it's not always going to be so obvious. Ah,
Oh, man.
groan. What? Santa,
La creepy little person keeps going for it.
Right?
Never made this, it doesn't get any worse.
No, sorry.
Bugs and kisses.
Are these two triangles similar?
No.
No, they're not.
Yes, they are. They are.
Yes, they
Yeah,
are.
they are.
Wait. Before we go. No, they're
No,
not.
yeah,
They're
they
not.
are.
They're not.
Yeah,
they're not.
yeah.
Look at 4. What's wrong with
Yeah.
4?
Oh.
Wait,
Wait, no, they're not.
No, they're not.
I switched my hands.
Yeah, that's right.
4 is like on the what side is 4?
Okay.
They don't have like the same.
Because
Raise your hand if you think they're similar.
has to fit that way.
Raise your hand.
Hey, go ahead.
Flip
Raise
it
your
in my
hand.
brain.
Raise your hand if you
Similar,
think they're
same
similar.
shape.
Raise your
No,
hand.
they're not.
Raise your hand if you think they're not similar.
Look at those angles though.
I got all you guys. Look, Rebecca's on the fence.
Because
I can't flip it in my brain.
All right.
I know it's
Well, they're the
yeah.
same
You gotta
shape,
invert it.
If you
But
do.
the ratios not.
Yeah. Then
Then
they're not. But if you.
Okay, let's help ourselves out. Let's say this is side A, this is side B, and this is side C. Okay? Clearly, this triangle doesn't look exactly like this one. It's like flipped or something, right?
Yeah.
But let's say we flip this triangle this way and then rotate it a little bit, right? And then I make this side C, and this side B, and this side A. 4 divided by 2 is
Then it would be
2. 6 divided by 3 is, and 8 divided by 4 is, so are they similar?
yeah.
They are similar. Now, this is a key point. Transformations don't necessarily matter. Translation and rotation. Translation and rotation and reflection. These are 3 types of transformation that won't change it. Translation is what? What's translation? You're just moving it. Translation means you're just kind of moving it. Moving side to side, up or down. Right? Or both. Right? Okay? Rotation is pretty clear. And reflection is also pretty clear. Right? If I translate it, or rotate it, or reflect it, it won't make a difference, right? What about if I scale it? If I scale it, would it make a difference?
No.
No. Right? So, with all these transformations that I could do to this polygon, doesn't matter. Because if I scale it, it'll still be similar. That's exactly what I'm doing here. I'm scaling this polygon, right? Because remember, scaling polygons, you go over 3 up 2, so I go over 6 up 4. You guys remember that?
Yeah.
Okay, so that was scaling, right? All these things, it doesn't matter. Okay? Polygon is still similar. Is that people understood? Okay, good. Now, right? Did you see Star Wars while you were in France, sir?
Did you see the stadiums when you were on
Okay.
It's like one of the most important rappers.
She's not a boy.
You don't have to be a boy to like Star Wars.
She doesn't like Star
About
Wars.
the stadium thing.
My dad wants to see it.
Should have gone.
The Star Wars is
Right.
the talking about.
What? When you were friends, did you go to the stadium as some friends?
No.
I didn't even know that.
That's Paris Saint-Germain. Herman. Alemán.
That's it.
Zlatan plays. Zlatan.
That may be you.
Yo,
Yo.
John, Ruben, hit me up.
Yeah?
I don't remember it.
Okay.
Whoa.
It's my first name, last name. and it's
Oh,
just-
okay, okay.
That's
I'm prepared.
What is this?
Hold on 1 second. Now,
We're drawing.
I'm gonna give you a couple minutes, see if you can solve for x and y based on this.
Give me a couple minutes just to draw.
Probably not. Probably
It's a little bit of a different scenario than what I presented to you before. See if you can figure it out.
Shut up, mate.
You remember what it is now?
Change something.
Hey, what's going on?
I'm just changing the color of your hand. Yeah?
Whoa. What's that?
Anybody have any idea? Do I see similar triangles here anywhere?
Yes.
Where are the triangles?
Inside the triangle.
There's a little one,
So
big one.
here's one triangle. Right? And then the bigger one is this one here. Now, there's one thing I really should have done. I mean, you had to just probably assume that these triangles were similar. But in order for me to show you for sure that they were similar, I would have had to say that these two lines are parallel. The reason being is that I know this line is parallel to that line, and this line has to be parallel because they're on the same line, right? So if this line is parallel to that line, what do I know about all the angles in these triangles? They must be congruent. If all the lines of the polygon are parallel, then all the angles must be congruent. So I know that the triangles are similar. Right? So did anybody solve for x?
Yeah.
Yeah.
What'd you get?
9.
We got 9.
9. Okay, well how'd you get that?
Divide by 2.
18 and 9.
Why'd you use half?
Because it's times 2.
Right, the ratio here is divided by 2 times 2, same thing, right? So x would equal 9. 18 over 2 equals 9. And what's y?
6.
How do I know it's 6?
Because it's similar.
Because this time I'm multiplying by, okay. And I'm multiplying y. Why am I multiplying instead of dividing? The other one I divided.
Because it doesn't have a number now. It's
Right. Here I was going from the bigger to the smaller. Here I'm going from the smaller to the bigger. That makes sense. Got that? Alright. That's pretty cool. Look how many colors we used. It's exciting. I just didn't
Who drew that?
Alyssa.
Which Alyssa?
Garcia.
Yeah, she was
Okay. I mean, every question really is just a variation of that type of thing, really. There's just algebra can be more or less complicated, but it's all basically the same. You know, it's the same idea. You know, the most important thing in this class is just to get the concept. Once you get the concept, it's just about applying it. And generally speaking, applying it means just do the algebra.
You should do riddles for us. Like
Okay.
mathematical riddles.
Oh,
Not really math. We used to have a teacher in 3rd grade, and she would
Sorry, can you give us a
draw a riddle on the board.
Yeah, it was really
And
cool.
then at the end of the week, we would have to like write up like the answer on a paper and then put it in this box.
Oh, I've got. Did you guys do those when Miss Brault was your sub? You didn't do them? Oh, so I have a bunch.
They're not like complicated. They're like
No, they weren't riddles.
Well,
they were
in
like
3rd grade,
Yeah.
you're in a different grade now.
Like she drew something. Like.
So, no. I mean, well, they'll be harder than they were. In,
but they're really fun.
I don't mean to
And
be
she
rude.
would like draw them. It wouldn't be like
That was
a
really
riddle.
neat. Yeah, they were fun.
We would love to.
At the end of the week, like,
And you can give us bonus points.
Class, everybody write this down. I'm not sure if I assigned it to you, but on page 377, don't do number 32. Page 377, X out, don't do number 32 in your homework. I'm not sure if I gave that to you, but just skip that one, okay?
Okay.
Thank you. Thank you very much. Okay. If I gave you something like this, I said this is 2x, and this is 60 degrees. Oh, never mind. Do number 32. Just kidding.
Oh, no.
Just kidding. I apologize. I apologize. But yeah, this is 2x, this is 60 degrees. This is x.
Everyone, I'm gonna be sorry. Some tape to break.
Whoa.
Okay. Solve for x and y. This is 2x, that's 60 degrees. This is x plus 40, and that's y.
X 40, Y is 80.
You're just giving away answers. You're giving away wrong answers too.
I didn't hear him.
No, watch.
You sure about that?
Ooh.
Come take a seat.
X
How could x be 4?
Because x plus 4 equals 2x. You subtract that.
For the record, I apologize. I needed to tell you that these sides are similar. These triangles are similar. This is side A, B, C. This is side A, C. How I could have written this, the way that this is written, say I wrote it like this. Like, this is the vertex A, B, C. This is vertex D, E, F. How I would write this is triangle ABC is similar, that's the sign, similar to triangle DEF. Okay, so this little squiggly, it's called a tilde really, is
A what?
tilde?
Or
T-I-L-D-E.
tilde.
Yeah,
Why?
that's Spanish.
Is that Spanish? Is that what the symbol looks like in
No,
Spanish?
it's just like a little, it's like an asterisk.
Oh, I could be wrong maybe, hold
Is that what
on.
it's called?
Tilde.
I was pretty sure that's called a tilde, but I could be wrong. Let me check it out.
It's not.
It's not. Waiting on.
Don't stop your mind.
Nope, that's a tilde.
Really?
In Spanish, I'm sure it might be different. No, a tilde is a. A diacritical tilde, you see?
That's what that is?
It's a diacritical tilde. Maybe there's a different type of tilde in Spanish, but in Spanish that sign is called a diacritical tilde.
You mean in math?
No, in math it's just a tilde.
Oh, in Spanish.
Anyhow,
My old
does everybody understand?
So we can check.
Okay, so did you solve?
Yeah.
Okay. Get this stuff. So what's x and y? Who can tell me? Bailey, can you tell me? What's x? 30. How'd you figure out x is 30? Right. We know that the angles must be the same, so 2x equals 60 degrees. Divide by 2, x equals 30 degrees, right? And if x is 30 degrees, Sarah, what's y? Got 50, okay. All right, well, let's see. If x is 30, that makes that angle 30 degrees plus 40 degrees equals 70 degrees, right? So if that equals 70, that equals 60. How do I solve for y? $60 degrees plus 70 degrees plus y equals 180, right? 60 plus 70 is 130 plus y is equal to 180. Subtract 130. And I get y equals what? Good job. So we solve for x and we solve for y. How do you guys feel about all this stuff? Excellent. Good? Alright. Well, that's it for the lesson for the day. That's pretty solid. Just reviewing our major concept. Similar triangles, the angles are, or similar polygons, the angles are
The same shape.
congruent. Similar means they're the same shape, very good, but the angles are, corresponding angles are congruent. And
All
corresponding sides, the ratios between them are the same. The ratios between corresponding sides are all the same. Very, very good.
Bye. Very good.
Goodbye.
Bye.
Have you exercised your mind today?
Snow.